In previous video, we started with a simple JavaFX project to implement a simple video game with a bear moving around the forest. We set up the project, we defined the different scenes and the logic to move from one scene to the next one. In this video, we are going to add some images to our video game and animate some sprites. Let's start by drawing an image into a scene. To do this, we need some images to be drawn. For this purpose, you can download a bundle of images that we are going to use in our video game. So we are going to create an assets subfolder in our project and drag and drop every image inside this subfolder. So first of all, we need to right-click on the project name and create a new directory. We can call it assets. In general, an asset is every media file that a video game needs. It can be an image file, a sound file, or so on. So in this subfolder, we're going to drag and drop the images that we need for our video game. These are the images that you can download from the resources below this video, and we need to drag and drop these images inside our assets subfolder. There is a background image with the forest, then there is a bear image with some sprites of a bear moving in every direction, and some images of fruits that we can use to fall down from the sky. So these images need to be dragged and dropped inside the assets subfolder. We can select all of them and drag them inside this subfolder. We choose refactor to include the images inside the subfolder, and then we have them inside our assets section. Now, if we want to draw any of these images in our scene, for instance in the game scene, we need to define an image object. There are many image classes in the Java API, but we need the one belonging to JavaFX scene image package. So we need to make sure that we import this package in our source file. Then we load the image file inside this image object, and using our graphics context object, we can draw it wherever we want. The first steps in our game scene class consist in defining a constant to store image location inside assets subfolder. In this case, we are going to refer to background image. Then we need to add an image attribute belonging to this image class from JavaFX scene image package. And inside the constructor, we try to load the image inside this file name into the background image object. So once we have this loaded, we can use this background object to draw the image in every place of our video game. Then we move to the draw method. We no longer need this show game message because we are going to draw a background that is going to fill the whole scene. So we can remove this instruction along with the corresponding method, and then we replace it with our background image. We use draw image from graphics context object, and we pass the background image to be drawn and the initial coordinates for its top left corner. So we are going to draw the background from the upper left corner of the scene, and we need to make sure that this background covers all the scene. So In this case, our background image has the same width and height than our video game. This is 816 pixels width and 480 pixels height. So if we try to run the video game now, we can see the background image drawn in our game scene. If we move with spacebar key to the game scene, we can see the background image drawn and covering the whole scene. Now we are going to draw the bear in the forest. But if you have paid attention to previous images, the bear image consists in some sprites of the same bear in different positions. So we need to choose one piece of this image to be drawn. In this section, we are going to learn how to cut and or scale an image to draw it in a scene. To do this, we can use draw image from graphics context object, but in this case we need to pass to this method some additional parameters. We need to pass the image to be drawn, in this case the image containing every sprite of the bear. Then we need to pass the x and y coordinates of the bear that we choose from this image, along with the width and height of the rectangle that we want to choose. For instance, this bear among every available bear in the image. Finally, we need 4 additional parameters referring to the scene: the x and y coordinates in the scene in which the bear is going to be placed, and the width and height of the bear in these coordinates. Remember that x and y coordinates always refer to top left corner of the image. For instance, let's choose this first image of the bear. The x coordinate of this image is 0 because it's the first coordinate of the whole image. And the y coordinate is also 0 because we are going to start drawing from the top left corner. And the width and height of every bear in this image is 96 pixels. So we can use these values to take into account the dimensions of every bear that we are going to use. Firstly, we need to repeat the same steps that we did before for the background. We are going to define a constant string to refer to bear image inside assets subfolder, an image attribute to store this image, and in the constructor we're going to load the corresponding image file inside the image object. Now we add this instruction inside our draw method from GameScene class to draw the bear just after the background. We choose the image to be drawn, bear image, the coordinates inside this image from the bear that we are choosing, along with the width and height of this bear, and then we choose the x and y coordinates inside the scene where the bear is going to be placed with the same width and height that it originally has. If we try to run the game now, we can see the bear placed more or less in the middle of the forest horizontally and in the floor of the forest. There is our bear, and if we try to change some parameters of this draw image method, we can see the effects of these parameters in the final result. For instance, if we change the y coordinate in the scene and we set it to 200, for instance, then the bear is going to be in the middle of the scene more or less. There it is, in the middle of the scene. because we have decreased the value of the y coordinate, so the bear moves up. What if we change the width and height of the bear in the scene, these two last parameters? For instance, instead of 96, we are going to set it to 200. We run the game again. And we can see that our bear is now much bigger because we have scaled the image to more or less its double width and height. So these are the parameters that we can use to draw an image in the scene in a desired position with a desired dimensions or size. But what if we need to move our bear or any image in the scene? We can use the keyboard, for instance, to press the left or right arrows and then make a specified image move in this direction. But then we need to store some additional information along with an image. In this case, we need to store the current x and y coordinates of the sprite in the scene so that we can press any arrow, left arrow or right arrow in our case, and automatically update these coordinates to draw the image, the bear in this case, in the appropriate position. To do this, we are going to define a sprite class that is going to store the sprite image, in this case the bear image, along with the current x and y coordinates. Besides, there can be subtypes of this sprite with a particular behavior. In our case, we are going to define a main character class that is going to be a subtype of sprite class to store every attribute inherited from sprite class, along with a new method that we are going to call move, that lets us move the bear in a particular direction. First of all, let's create an additional package inside our video game package. Let's call it videogame.sprites. And inside this package, we're going to add every sprite needed for our video game. This can be our sprite class with some attributes: sprite width and height, current x and y coordinates, x and y coordinates inside the image for the chosen sprite among every available sprite in the image, and the whole image that we're going to manage. In our case, the whole bear image with every bear sprite, and we are going to choose a given sprite in a given moment through these two attributes. In the constructor, we simply set the width and height of the chosen sprite, and we can add some additional methods that can be really helpful. For instance, move_to method lets us change current position of the sprite in the scene, choosing new x and y coordinates. Then we can add the getter from x and y coordinates in the class, and a draw method that lets us draw the image in a given graphics context, specifying the x and y coordinates in the sprite image, the width and height that we want to cut from that image, and the coordinates in the scene along with the width and height of the sprite in the scene. In our case, we are not going to scale in any image, so the width and height of the sprite in the original image are going to be the same than the width and height that this sprite is going to have in the scene. Regarding our main character class, it extends sprite class, and we can define some helpful constants in it. For instance, we can define the bear width and height 96 pixels, the location of the bear image inside our assets subfolder, and 2 additional constants to refer to left and right movements that we assign to 0 and 1 values respectively. In the constructor, we can load the bear image as we did before in the game scene and choose one sprite inside this image to move around the forest. For instance, the first sprite corresponding to 0 coordinates. We can add another method called move to move the sprite in a given direction that is passed as parameter. If this direction corresponds to left constant, then we move the character to the left by decreasing its x coordinate, and if the movement corresponds to right constant, then we move the character to the right, increasing this x coordinate. In our game scene class, we no longer need this image because we are going to use our main character object, so we replace this image class with a main character class. We need to import this class because it belongs to a different package. And then we need to initialize the main character inside this game scene constructor. Instead of creating a new image, we are going to create a new main character. So we no longer need this constant because we have moved it to a main character class. And we no longer need this instruction to draw the bear because we are going to draw it from the draw method of sprite class. So we can replace this instruction with draw method inside bear object, passing the graphics context as a parameter. Finally, we need to deal with the keyboard and identify whenever user presses left or right arrow keys. To do this, we add these two else-if blocks to identify if user presses left key or right key. If he presses left arrow key, then we call to move method inside bear object, indicating that we want to move the bear to the left. Otherwise, if user presses right arrow key, we call the same method, indicating that we want to move the bear to the right direction. Finally, we need to locate the bear in an initial position, otherwise it's going to be placed at the top left corner of the scene. So we can place it before starting the animation timer in an appropriate position. If we try to run the game now, we can see our bear placed in an appropriate position, and if we press left or right keys, we can see how the image moves to left or right respectively. Okay. It's important to notice that the order in which we draw the images is really relevant for the final result. For instance, if we draw the bear before the background, then the bear is placed behind the background and we can't see him. Okay, we can't see the bear because the bear image has been placed behind or before the background image. So it's important to draw this image after the background. To finish with this video, we are going to see how to animate our bear. Obviously, we can't pretend to move the bear without animating it, because it doesn't seem a real bear moving around the forest. So how to animate a sprite? We need to add an additional class inside our sprites package. We can call it animated sprite, and it's going to represent every sprite in the video game that needs to be animated. In order to animate a sprite, we need to store all the possible sprites, all the possible images representing a given movement. For instance, if we want to move the bird to the right, we can focus on 3 or 4 different images in our bear image and alternate these images as user still presses the right key. For instance, we can start with the second image and then move to the third one. From the third one, we can go back to the second image, then to the first one, and from the first one, go back to the second. So we can define some kind of cycle among these images to alternate them and simulate that the bear is actually walking to the right in this case. The animated sprite can be like this one. It's a subtype of sprite parent class. We can define the different movements that an animated sprite is going to have. In this case, we can define 2 different movements, to right or left, on left and right as we prefer. And we need to include some additional attributes. In this case, we need to use the current direction of our sprite, either left or right in this case, the current sprite that is going to be drawn among the different sprites for the given direction, and a bidimensional array to define x and y coordinates for every movement, for left and right. Later we will see how to fill this array. In the constructor, we set the width and height of every sprite in this case, along with the current initial direction. For instance, the bear is going to look right at the beginning, and the current sprite of the sequence of the right animation. We also include an additional method that we can call animate to animate the sprite in the given direction. So if we change the direction, if we change from left to right or vice versa, then we change current direction attribute and we start the animation from the first sprite of this direction, either left or right. Otherwise, if we keep moving in the same direction than in previous iteration, the previous iteration of the loop, we can just increase the sprite to be drawn among every available sprite in this direction, either left or right. Finally, we update the sprite coordinates to be drawn among the available sprites in the image. Let's see how to apply this class to our main character. Now our main character is no longer extending sprite class. From now on, it's gonna be a subtype of animated sprite. Okay? We no longer need these 2 constants because they are already reflected in our animated sprite class here. Okay? And then we need to make some additional changes in the constructor and some other methods that we have below. There is a mistake here. We need to fix this class name, and then we need to add some changes to these methods. First one is that we no longer need this static fixed x and y coordinates for a given chosen sprite. Instead of this, we are going to play with different sprite coordinates inside our bear image. In our case, we are going to work with 3 different images to make the bear move to the right, and another 3 different images to make him move to the left. These images are located in these different coordinates. So if we go back to the bear image, we can see where these images are located. Regarding the right movement, we're going to focus on images placed are 480, this is this image, 576, which is next image, and 672, which is next image. And we are going to alternate this image in time to simulate the right animation. If we refer to left animation, then we are going to use these 3 images that are placed in these 3 x coordinates. The y coordinate for every image is 0 because it's a horizontal image and every sprite in this image has the same y coordinate. So we are going to rotate these 4 coordinates in our animation either to the right or to the left in our bear. Regarding the move method, we just need to add an additional instruction at the end to call the animate method from parent class and specify that we need to animate the bear in the specified movement. Now we can try to run the game and see how our bear moves. As you can notice, when you start moving the bear, he moves too fast. He alternates the images, the sprites, too fast. So we need to slow down this animation in order to be more real. We need to define an additional constant in animated sprite class to represent the sprite change rate. After every 5 iterations of our animation loop, if we still press left or right arrow key, we are going to change the sprite. Instead of changing it after every key pressed, we are going to wait until 5 consecutive key pressed before changing the sprite. So the sprite animation is going to slow down 5 times. Then we add an additional attribute to define a counter for this sprite change. When this counter reaches this top limit of 5, then it's going to be set to 0 again, and the sprite is going to effectively change. In the constructor, we initialize this attribute to 0, and inside the animate movement, we are going to apply this instruction to change the sprite only when this attribute reaches the maximum value specified in this constant. If we change the direction of our movement, then we set this attribute to 0 again, but if not, if we are still moving in the same direction, then we need to check this maximum value. So we increase the attribute current sprite change, and whenever it reaches the maximum value, then we set it to 0 again and change current sprite to be drawn among the available sprites in our array. If we try again, we can see that now our bear moves more accurately in a more real and fashionable way. So there's just one thing pending. What if we need to move faster? We need to pay attention to the move method inside our main character. In this move method, we are just moving from 1 pixel to 1 pixel. But what if we need to move faster? We can define a constant here. We can call it step and set it, for instance, to 4. And then instead of moving from 1 to 1, we can move the bear from step to step value. So if we need to move faster or slower, we just need to change the value of this constant. We can check this and see how our bear moves faster now. There it is, how he can move faster from one edge to the opposite one. Okay, so he'll be able to reach the fruits that are falling far from his current position. And that's all. We have learned how to draw images, how to place them in a given position, and how to animate some given elements in our video game. In next videos, we'll see how to check collisions so that we can detect if our bear catches the fruit falling from the sky, and we can also avoid that our bear exceeds the limits of the scene. Okay, but that will be in our next video.